Hello. Today I'm going to explain why the three major exponent rules, which you see over my shoulder here, why they are true. You can just memorize them, obviously, and most math teachers will of course require you to do that. In fact, many of them will simply require you to do that and will not ask you to think very hard about why they're true. However, I'm going to explain exactly why these have to be true, and deeply understanding this reasoning can help you very much in correctly using exponents as you move forward. So I strongly recommend that you think carefully about the ideas that are discussed here. All right, I'll read the rules quickly. You've probably learned them recently, that a to the m times a to the n is a to the m plus n. A to the m raised to the power of n is a to the m times n, not the addition, but the multiplication of the two numbers. And then if you take a to the m over a to the n, that is supposed to be equal to a to the difference between those two numbers, where you take the top one and subtract off the bottom. And the question is, why? So I've written Q here to mean the question. The answer actually comes from all three of them, come from really the definition of an exponent. So I need you to think about this for a moment. If you have a to the mth power, what does that actually mean? What does it mean if you take 5 to the power of 3? So I'll finish this in a moment, but I want to think of an example here, and I'll erase it. And then we'll fill in what this means in a moment. Think about 5 to the third. You probably can remember what that is, not as a number, as a value that you've memorized, but you think about how you calculate it. What that means is you take 5 times 5 times 5, 3 times. This is that number multiplied by itself that number of times. It's not added, by the way. It's a common misunderstanding. I'll just say note. It is a common misunderstanding to think that it might be 5 plus 5 plus 5. But that's actually what 5 times 3 means. So just notice that 5 to the third and 5 times 3 do have strong similarities. Both of them involve 3 5s, but one of them is multiplication, the other is addition. Make sure you really pay attention to that difference. Okay, now that we've thought that through, let's write down the definition of a to the m. Now I'll notice this definition only works if m is a whole number bigger than 1. But for now, let's just assume that m is some number that's like 5 or 6 or 7 or some number like that. And what that means is it's a times a times a times dot 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 some number of times until you get to the last a, where this in total is m of these a's, whatever m is. That's what the definition of an exponent is. And all three of these are true because of this. That's what we're going to focus in on. Keep paying attention to this definition. Okay, so for problem number 1, rather than try to explain why it's generally true, let's look at an example. Why is 5 to the third times, say, 5 to the fourth, why is that equal to 5 to the 3 plus 4? Why not 3 times 4? Why does this rule on the right work? The answer is to say, well, by the definition of an exponent, think about what 5 to the third means. This means 5 times 5 times 5. That's what this one is. This time symbol is this one. Notice there are other ones implied inside of here, that this one is this one, and then this 5 to the fourth is 5 times 5 times 5 times 5. And when you look at what this actually means, by thinking about this, it's obvious why it's an addition of exponents. Because literally, there are 3 of them here and 4 of them here, and so there's a total of 3 plus 4, there are 7 of them. And so, of course, it's 5 to the 7th. And so I would ask you all, that's the answer. That's the answer why a to the m times a to the n is a to the m plus n. And I'm going to strongly suggest that for the near future, when you see things like this in your math class, rather than just jump to a memorized rule, oh, I always add the exponents, I suggest that you consider for a while why this is x to the 8th. See in your mind's eye 5 x's being multiplied. See in your mind's eye 3 more x's being multiplied. See in your mind's eye 8 of them there. And then it'll be really clear and the rules will start to stick. So of course that's x. All right, let's look at a second example because I'd like to explain why the second one's true. So here, let's ask, why is it that if you take 5 to the third and raise that to the fourth, why is that 5 to the 12th and not 5 to the 7th? Well, again, let's use the definition. So here's the question. Why is that equal to 5 to the 12th? And the answer is to say, well, think about what 5 to the third is. It means 5 times 5 times 5. Now we're raising it to the fourth power. Now think about what that means. 5 times 5 times 5 to the fourth literally means we're going to take this thing and multiply by itself 4 times. So it means 5 times 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 5. It's 4 groups of 3 fives. And 4 groups of 3 things is 12 things. That's multiplication. That is 5 to the 12th. And so, of course, 5 to the third to the fourth is 5 to the 12th because of that. And again, I would invite you in the near future, when you see things like x to the third to the fourth, rather than simply jumping to the memorized rule, I suggest that you instead think about x, 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 and see the 12 of them. And the more you do that, the more this set of rules is going to seem very natural and correct to you. And you'll memorize it better. The last one, because now we've shown that a to the m to the n is, of course, a to the m times n. Let's look at the last one. The question is, why is something like 5 to the 6th divided by 5 to the 2nd? Why is that equal to, it says to subtract, why is that equal to 5 to the 4th? Why not 5 to the 3rd? Why not 6 divided by 2? Why is the rule subtraction? Well, the answer is, again, to just think about what 5 to the 6th means. It means 5 times 5 times 5 times 5 times 5, 6 times, divided by 5 times 5, 5 to the 2nd. And notice what you can do when you have multiplication on the top and the bottom, and you're dividing, these two cancel. These two cancel. 5 over 5 is 1. 5 over 5 is 1. This is really 1 times 4 fives. It's 5 to the 4th. That's the reason why this rule works, because of the cancellation. Now, if you notice, my example had that top number bigger than the smaller number. If it's flipped, something different happens here. Then the cancellation happens where you end up with things on the bottom. My advice, don't worry about that right now. Just understand the rule generally in this way, and we'll talk later in a different video about negative exponents and when these powers actually have the larger power on the bottom. Hope that helps.